and welcome dear students. Today we are going to discuss the topic ocean floor features of Atlantic and Indian Ocean. The ocean floor exhibits a highly varied and complex topography which is far from flat. Detailed understanding of the submarine landscape became possible only after the widespread adoption of modern techniques such as echo-sounding, bathymetric mapping, and seafloor sampling from the 1930s onward. Advances in data collection have progressively revealed the intricate and heterogeneous nature of seafloor relief. Nevertheless, based on consistent morphological patterns, the ocean floor of a typical basin can be systematically categorized into major and minor relief features. Major features include the continental shelf, continental slope, continental rise, abyssal plains, and deep sea trenches. Minor features encompass a diverse array of forms such as ridges, hills, seamounts, guyets, submarine canyons, fracture zones, island arcs, atolls, coral reefs, submerged volcanoes, and sea scarps. These features result from the interplay of tectonic, volcanic, erosional, and depositional processes. The study of seafloor topography, therefore, constitutes a fundamental aspect of oceanography, contributing essential insights into the origin of marine landscapes, geological history, and distribution of the oceanic ecosystems. The global distribution submarine elevations can be quantitatively represented by a hypsometric curve. This graph plots the cumulative percentage of under Earth total surface area that lies above or below a given elevation or depth relative to a datum, typically mean sea level. Scientifically, the detailed mapping of the ocean floor, known as bathymetry, constitutes a foundational discipline within oceanography. Bathymetric data are critical for elucidating the three-dimensional structure of the seafloor, interpreting its geological features, and understanding the distribution of associated benthic ecosystems. Modern high-resolution bathymetric surveys are conducted using advanced platforms such as remotely operated vehicles and autonomous underwater vehicles. This mapping enables the identification and analysis of key submarine features, including mid-oceanic ridges, trenches, and seamounts, which yield essential insights into plate tectonic processes, crustal formation, and the genesis of mineral and hydrocarbon resources. So far as the oceanic floor of Atlantic Ocean is concerned, the Atlantic Ocean constitutes a primary basin within the global oceanic system, distinguished by its significant scale and complex dynamics. The Atlantic Ocean, with an approximate surface area of 106.46 million square kilometers, it occupies roughly 20% of the Earth's total surface area and 29% of its hydrosphere. Its morphology is characterized by an elongated sinus S-shaped basin that extends longitudinally, demarcating the continents of Europe and Africa to the east from the Americas to the west. The Atlantic is commonly subdivided by oceanographers into two major biogeographic and physical provinces. The North Atlantic and the South Atlantic Oceans, partitioned approximately along 8° north latitude by equatorial countercurrent. Oceanographically, the Atlantic exhibits significant physiographic and hydrodynamic complexities. Its bathymetry is characterized by a prominent mid-ocean ridge system. The mid-Atlantic ridge, which serves as a divergent tectonic boundary and profoundly influences seafloor topography, including abyssal plains, seamounts, and trenches. The Atlantic circulation is dominated by major current systems such as the Gulf Stream, the North Atlantic Drift, and the Canary Current, which are integral components of the Atlantic meridional overturning circulation. The Atlantic basin contains numerous archipelagos and isolated island systems, such as the Azores, Bermuda, and Canary Islands, the Cape Verde archipelago, and the islands of the Caribbean, many of which are of volcanic or tectonic origin. So far as continental shelves are concerned, the continental shelves of Atlantic Ocean represent the submerged, gently sloping extensions of the continents formed from the continental crust and bounded seaward by the shelf break. These shelves display remarkable variability in width, ranging from narrow zones of less than 5 kilometers to expansive platforms over 400 kilometers across. This morphological diversity is systematically controlled by tectonic setting, coastal geomorphology, and glacial history. Narrow shelves are typically found along tectonically active margins or where high relief coastlines, such as mountain ranges, limit sediment accumulations. Prominent examples include the steep western African margin between the Bay of Biscay and the Cape of Good Hope and the eastern Brazilian coast near 5 degrees to 10 degrees south latitude. In contrast, broad shelves develop along passive trailing edge margins that have undergone prolonged subsidence and received substantial sedimentary input from major river systems and Pleistocene ice sheets. Notable examples include the Grand Banks of Newfoundland, the Dogger Banks in the North Sea, the shelves surrounding Greenland and Iceland, and the extensive southwestern Atlantic shelves between Argentina and the Antarctic Peninsula. The Atlantic shelves also host several semi-enclosed and enclosed seas, predominantly in the northern hemisphere, shallow shelf-seated epicontinental seas such as the North Sea, the Baltic Sea, and the Hudson Bay overlie continental crust. In contrast, large enclosed basins like the Caribbean Sea and the Mediterranean Sea possesses more complex tectonic origins and oceanic or transitional crust, though they are often considered within the broader geographical context of Atlantic marginal seas. So far as the mid-Atlantic ridges are concerned, the mid-Atlantic ridge is a predominant physiographic feature of the Atlantic Ocean basin, representing a divergent plate boundary. The mid-Atlantic ridge extends approximately 14,450 kilometers from north of Iceland in the Arctic to the Bouvet Island region in the Southern Ocean. Its trace generally follows the S shape of the Atlantic coasts. It maintains a central position within the ocean, and despite lateral deviations, its crust rarely descends more than 4,000 meters below sea level. The ridge system is not a single uniform structure but includes several named segments and associated bathymetric highs. North of the equator, it is historically termed Dolphin Rise, and to the south, it is named as Challenger Rise. The segment between the Iceland and the Scotland is identified as the Will-Thomson Ridge. South of Greenland and Iceland, it borders into the Telegraphic Plateau, named for its role in early transatlantic telegraph cable laying. Near 50 degrees north, a significant branch, the Newfoundland Rise, extends northwest towards the Newfoundland margin. At south of 40 degrees north, the Azores Rise bifurcates and extends towards the Azores Islands. Near the equator, the ridge sends off two branches, the Sierra Leone Ridge northeast and the Para Rise northwest. A smaller Guiana Rise extends northwards towards the Guiana coast. Near 40 degrees south, two major features emerge. The Walvis Ridge, extending northeast to the African continental shelf, and the Rio Grande Rise, extending towards the South American coast. Though largely submarine, The mid-Atlantic ridge is punctuated by volcanic peaks and seamounts that project above sea level to form islands, such as those of the Azores Archipelago. Pico Islands is a notable example with its summit reaching approximately 2,351 meters above sea level. The ridge axis is systematically offset by a major transform fault manifested as fracture zones. Now discussing the mid-oceanic basin. The Atlantic Ocean basin is structurally organized into several major physiographic provinces known as deep sea basins. These expansive, relatively flat abyssal plains are bounded by continental margins on their western and eastern flanks and are separated from one another by prominent topographical elevated axes of the mid-Atlantic ridge. This submarine mountain range effectively partitions the ocean into two primary parallel abyssal systems: the West Atlantic basins lying between the Americas and the mid-Atlantic ridge, and the East Atlantic basins situated between the mid-Atlantic ridge and the continents of the Europe and Africa. Each system comprises a series of discrete deep sea basins, which are large-scale depressions in the oceanic crust characterized by distinct geomorphology, sedimentology, and depth profiles. So let us look on the West Atlantic basin. So first we will just see the Labrador basin, situated between the continental shelf of Greenland to the north and the Newfoundland rise to the south, approximately from 40° north to 50° north latitude. The basin floor ranges in depth from 4,000 to 4,500 meters. Second is the North American basin, the most extensive basin in the Atlantic Ocean, extending from roughly 12° north to 40° north latitude. It is bounded by continental shelf of North America to the west and the mid-Atlantic ridge to the east. Depths generally exceed 5,000 meters. It encompasses the Sargasso Sea region within its surface waters. Let's have a look on the Brazilian basin, which confined between the equator and 30° south latitude. This basin is bordered by the east coast of South America to the west and the Paraíso to the east. Depths are typically greater than 4,000 meters. So far as Argentine basin is concerned, which is located from approximately 35° south to 50° south, this basin is notable for its significant depths, which ranges from 5,000 to over 6,000 meters, forming one of the deepest parts of the South Atlantic. So moving to the East Atlantic basin, where we have Iberian basin, which is positioned between the mid-Atlantic ridge and the Iberian Peninsula. It is bounded to the south by the Azores Rise and extends to about 50° north latitude. Its average depth is approximately 5,000 meters. So far as Canary Basin is concerned, which is lying between the mid-Atlantic ridge and the West African coast from roughly 10° north to 30° north latitude, the average depth is around 4,000 meters. So far as Cape Verde Basin is concerned, which is located between the Guiana Ridge and the Sierra Leone Rise, this elongated basin trends from northeast to southwest. It has depth ranging from 4,000 to 5,000 meters. So far as the Guiana Basin is concerned, which is situated south of the Sierra Leone Rise, extending in an elongated shape, it represents a major depression in the eastern tropical Atlantic. Next is the Angola Basin, which is extending from the equator to about 30° south latitudes. It stretches from the African coast to the junction of the mid-Atlantic ridge and the Walvis Ridge. It has an average depth of about 5,000 meters. So far as Cape Basin is concerned, which is located between the approximately 25° south and 45° south latitude, offshore of the South Africa. Agulhas Basin, which is situated further south from about 40 degrees south to 50 degrees south, where the Atlantic and Indian Ocean water masses interact. Let us now discuss the ocean deeps. The bathymetry of the Atlantic Ocean is distinguished by relatively scarcity of the classic linear deep sea trenches when compared to the circum-Pacific subduction system. This morphological contrast is a direct consequence of the Atlantic's overarching tectonic framework, which is dominated by passive continental margins and a central divergent plate boundary. The absence of widespread tertiary and ongoing subduction along most of its periphery has precluded the formation of extensive archaic trench system. Instead, the profound depths of the Atlantic are localized within discrete, deep, isolated bathymetric depressions, often exceeding 5,500 meters. Early systematic surveys, such as those conducted by John Murray, catalogued fewer than 30 such features. The most notable include the Puerto Rico Trench, which is approximately 8,385 meters, marked the ocean's deepest point within a subduction zone linked to the Lesser Antilles Island arc, the Romantic Trench, approximately 9,370 meters. A transform related deep along the major Romanche fracture zone and a Nares deep, other significant deeps such as the Hatteras, Columbia and the Weimar deeps are predominantly associated with major fracture zones, extinct rift structures or other complex crustal discontinuities rather than with active continent consuming subduction. The Caribbean Basin is not a uniform depression but a composite of several smaller basins including the Yucatan, Colombian and Venezuelan basin delineated by submerged ridges. Now we will just discuss about some of the prominent bottom relief of Indian oceans. The Indian Ocean constitutes the world's third largest oceanic basins by surface area. It accounts for approximately 1/5 of the total tectonic area globally. It is uniquely enclosed on all sides by major land masses: Asia to the north, Africa to the west, Australia to the southeast, and Antarctica to the south. The ocean's mean depth is approximately 4,000 meters, which is less varying and comparatively lesser than that of the other oceans. Out of the total area, the deep sea plains covers about 58.8% area. Geologically, extensive sections of its continental shelves are formed by the stable crystalline blocks of the ancient Gondwana craton. In contrast, the tectonically active margins of the East Indies are characterized by Cenozoic fold and thrust belts. The ocean possesses comparatively fewer peripheral seas. The principal marginal basins include the Arabian Sea, the Bay of Bengal, the Andaman Sea, the Mozambique Channel, the Red Sea, and the Persian Gulf. Its islands inventory is dominated by a few large land masses such as Madagascar and Sri Lanka, alongside numerous smaller island groups and archipelagos. These include the Seychelles, Maldives, Lagadives, Andaman and Nicobar Islands, as well as volcanic and isolated outcrops like Reunion, the Comoros, the Kerguelen Island and the Christmas Island. A primary physiographic feature is the bifurcation of its north section by the Indian subcontinent, which creates the distinct basin of the Arabian Sea and the Bay of Bengal. Based on the regional characteristics, Johnson classifies the Indian Ocean into three distinctive zones. The western zone, situated between the African coast and the mid-Indian Ocean ridge, is characterized by a high density of islands. Its average depth is approximately 3,650 meters. The eastern zone is the deepest of the three with an average depth of about 5,500 meters. This region features narrow continental shelves that descend via steep slopes into the abyssal plain. The central zone is defined by topographic prominence of the mid-oceanic ridge system, which is dotted with the numerous small islands and seamounts. So far as it is continental shelf and slopes are concerned, the continental shelf bordering this ocean exhibits significant regional variations in width. On average, the shelf is narrow, measuring approximately 96 kilometers, though notable expansions occur in specific basins. For instance, within the Arabian Sea, the Bay of Bengal, and the Andaman Sea. Shelf width increases considerably, ranging from 192 kilometers to 208 kilometers. A particularly extensive shelf, approximately 960 kilometers wide, is present between Australia and New Guinea. The most extensive shelf development is observed between Australia and New Guinea, where it extends up to 960 kilometers. In contrast, the shelf structure adjoining Antarctica is highly complex due to intense glacial processes. Here, the inner shelf is notably deep, about 150 to 200 meters, while the outer shelf descends to 400 to 500 meters. Seaward of the shelf, the continental slope is often exceptionally steep, with gradient angles commonly varying from 10 degree to 30 degree. The shelf itself is frequently incised by submarine valleys and canyons, while the shelf width along the African coast is close to global average. It broadens notably around Madagascar. Similarly, the shelves adjoining the island of Java and Sumatra extend approximately 160 kilometers in width. So far as it is mid-oceanic ridges are concerned, the mid-Indian Ocean ridge extends in a roughly north-south orientation from the south tip of the Indian Peninsula to the Antarctic continent. Where this central ridge rises above sea level, it forms volcanic island chains. Its northern section, known as the Laccadive Chagos or Maldive Ridge, originated at the Indian continental shelf with an average width of 320 kilometers. Continuing southward, the features widened near the equator and is designated the Chagos-St. Paul Ridge between the equator and 30 degrees south latitude. It broadens significantly to approximately 1600 kilometers between 30 degrees south and 50 degrees south, forming the Amsterdam-St. Paul Plateau. South of 50 degrees south, the ridge bifurcates into a western branch, the Kerguelen Gosberg Ridge, and an eastern branch, the Indian Antarctic Ridge. This central ridge system gives rise to several major subsidiary ridges. The Socotra-Chagos Ridge diverges northward from the main ridge near 5 degrees south, extending to the Godefroy Peninsula of the northeast Africa. The Seychelles-Mauritius Ridge branches near 18 degrees south and curves northwest towards the Seychelles and the Amaranth Island. The Madagascar Ridge stretches south from Madagascar, continuing beyond 40 degrees south as a Prince Edward Crozet Ridge. A significant southward branch near 23 degrees south is identified as the Southwest Indian Ridge. A distinct non-spreading feature, the 90 East Ridge, runs linearly north-south along 90 degree east longitude from the continental shelf of the Irrawaddy River mouth until it merges with the Amsterdam-St. Paul Plateau near 40 degrees south. While discussing its ocean basins, the mid-Indian Ocean ridge serves as the primary bathymetric divide, separating the Indian Ocean floor into two major provinces, the eastern and the western basin. These are further subdivided by ridges, various branches and other prominent submarine features into a series of discrete abyssal plains and depressions. In the western sector, the Arabian Basin forms a near circular depression between the Lac-Cadou Chagos and the Socotra Chagos ridge, averaging 3,600 to 5,486 meters in depth. To its south, the Somali Basin is enclosed by the Socotra Chagos Ridge, the Central Ridge, the Seychelles Mauritius Ridge, and the African continental margin with an average depth of 3,600 meters. Southeast of the Madagascar, the oval-shaped Mascarene Basin lies between the Madagascar Ridge and the Seychelles Mauritius Ridge. Further south, the Mauritius Basin, bounded by the Southwest Indian Ridge and the Madagascar Ridge, features depth ranges from 3,600 to 5,400 meters, with its deepest point recorded at 6,391 meters. Adjacent to the African coast, the elongated Agulhas Natal Basin is demarcated by the Madagascar Ridge, the Prince Edward Crozet Ridge, and the southeastern Schelp, maintaining an average depth of 3,600 meters. The southern and the eastern parts of ocean are characterized by several major depressions. The Atlantic Indian Antarctic Basin represents an eastward continuation of its Atlantic counterpart, extending to 70° east longitude and bordered by the Prince Edward Crozet Ridge, Antarctica, and the Kerguelen Gosberg Ridge, with an average depth of 3,600 meters. The eastern Indian Antarctic Basin lies between the Amsterdam-St. Paul Plateau, the Indian Antarctic Ridge, and the Antarctic continental, with depth ranging from 3,600 to 4,800 meters. It is separated from the aforementioned Atlantic Indian Antarctic Basin by the Kerguelen Gosberg Ridge. The most extensive of all is the West Australian Basin, a broad rectangular depression enclosed by the Southeast Indian Ridge, the 90 East Ridge, and the continental shelf of Java, Sumatra, and Western Australia. Its depth varies from 3,600 to over 6,100 meters, with the central abyssal plain reaching 6,459 meters. Finally, the mid-Indian Basin occupies the area between the Central Ridge and the 90 East Ridge, averaging 4,800 meters in depth. A significant sub-region within it is Wharton Basin, located south of the Bay of Bengal between the 90 East Ridge and the Broken Ridge. Now coming to the deeps and trenches. The bathymetric profile of the Indian Ocean is dominated by its abyssal plains, which constitutes approximately 58.8% of its total area and lie at depth ranging primarily from 4,000 to 6,000 meters. In contrast to the Pacific and Atlantic Oceans, it contains comparatively few ultra-deep trenches. A notable exception is the Sunda Trench, also known as the Java Trench, which reaches a maximum depth of 7,450 meters. This was all about today's lecture. Hope you have enjoyed it well. Thank you for watching.